I took calc-based economics in college. And you're trying to maximize profit, right? Like trying to find the best way to maximize profit. How many like phones should I produce? How much should I charge? And you get into like these profit curves, and you're trying to find like the peak. That's an example. Or I've got this product I want to sell, and I want to put it in a box, but I don't want to like waste material, so I want to use the least amount of material that'll give me the biggest amount of value to hold my thing. These are real life situations where you're trying to make something as big or as small as you can. This is a little less like real life applicable, but this is a good example. I want to find two numbers whose product is as large as possible. So you're always going to have like one thing you're looking for. It's called optimization. This is the section. We're trying to find either the maximum or the minimum of something. In this case, we're trying to maximize the product. In this case, we're trying to minimize the distance between this point and the curve. In this place, we're trying to maximize the volume. So we're trying to get like the optimal outcome of something. Sometimes you can able to do that with one equation. Sometimes it'll take you two equations. So if I look at this one, product is as large as possible. Any two numbers. You can call them A and B, you can call them X and Y, whatever. Let's say I call them A and B. I'm looking for the product of those to be as large as possible. So that means A times B equals max. That's as big as I can get. But what I want to be able to do with this is take the derivative of it. Because that's how we find my relative max and relative min, right? Is the derivative level. So I want to be able to take the derivative of that. But right now there's two variables. Let's use X and Y. So this is going to be X times Y equals max. So what I want to do with that is take the derivative of it, set it equal to 0, figure out where there's a max and where there's a min. But I can't do that until there's one variable. So they'll have to give you, in these situations, a second equation that you can use to turn that equation into something with one variable. So doesn't this also tell me that X plus Y has to equal 30? So this is the main guy here that we're trying to work with. But this second piece of information will allow me to write this so that it's only one variable. So we're going to use substitution. It doesn't matter which variable you solve for. Let's say I solve this for X. X would then equal 30 minus Y. Agreed? Which means then I can say, well, I can say 30 minus Y times Y equals max. Because all I did was take the 30 minus Y and sub it in for the X. Today, we're going to get to there and stop. So you're going to go through every prompt they give you and just set up the situation where you are trying to maximize or minimize whatever they're saying, and you have one variable. And then Monday, we'll get into what to do from that point. But the setting up, I think, is the harder part. Yeah.
How did it switch to 30 minus Y times Y? Oh, no, never mind. I see.
So it's... Yeah, well, you're not the only one. So I had X times Y. I still have X times Y, but I just wrote X like this so that I only have one variable. Other questions on one? Second one. So what point of the graph here is closest to 5, 0? So I think the true answer is like a right angle. So somewhere around there is probably your closest. But any point on this graph is X, Y, right? Like any point on any graph is X, Y. Well, I'm going to do don't write anything down yet, just kind of watch me like do it and I'll fix it. I'm going to do the distance formula. Closest to means distance formula. You guys remember the distance formula? So I'll write the formula first. You might want to write that down. It's just Pythagorean theorem. You're kind of making a triangle, and this is the Pythagorean theorem from that. But that's the distance formula, and that's fairly common in these, so you want to write that down. So my 2 points are 5, 0 and X, Y. So like what I first might do, this is what I say, don't write this down. What I first might do is say, okay, x minus 5 squared plus y minus 0 squared. So I'm taking the x, I'm subtracting the x value, I'm subtracting the y values. It doesn't matter which order, just do them in the same order. Although, I don't even know if that matters. Because you're squaring them anyways. Whatever, okay. But what's the problem with this? 2 variables. I want 1 variable. What can I do? Plug in what? Yeah, good. This is my secondary equation right there. So y is equal to the square root of x. So isn't every point on the graph technically just x times the square root, or x comma square root of x? Because y is equal to the square root of x. Right? That's the equation they gave me. So then the way you should actually write this would be x minus 5 squared plus the square root of x minus 0 squared. So we're using this point and this point and finding the distance between them. But again, next week we'll take the derivative of something equals 0 and next off. Today we're just setting off. That is, yeah, I would write down what you see now. Yeah. Sorry, I finished the set, like, stop writing and never told you to start again. I guess we're all just waiting. Yeah, restart right. Resume. While you're doing that, I'm going to do a physical demonstration. Magic cards, of course. Calculus teacher is doing magic cards. Bunch of nerds. So if you read through the next one, I'm trying to like create that. I'm cutting a square out from every corner of, pretending this is a 14 by 30 sheet of cardboard. And then if I fold up the parts that are left here, it makes a little box, right? Without a top line, but it makes a box. So I cut out a square. And then the question is, what square should I cut out so that this box holds as much in there as it possibly can? So the largest value. So should I cut out like halfway, a little less than halfway, a little more than like this cut that I made? How big should it be? That's what we're looking at. What's the biggest the cut could be, but it couldn't actually be this number? Does that question make any sense? So I couldn't cut 14 inches from both sides. So I could cut up to 7, but not 7 inches from both sides, right? I could cut like 6.99 inches from both sides. But if I cut 7 from 14, it's not a box. So the biggest you could possibly get would be like almost 7. So we want to write an equation that maximizes volume. So volume is length times width times height, right? Well, I just took a box and this is 14, this is 30, but then I cut a square like x by x from every corner. So what I have now is more like that. Let's undo that. I don't know if that's the most helpful way to Sorry. That right there, when I fold it up, that's like this piece. When I fold it up, the x becomes the height. So whatever I cut out becomes the height of it, right? Because I'm folding that piece up. And then the length of it is like whatever's left over. So this little bit here, when I fold it up, those are gone. So that's going to show me just the width of the box. What is the length of this? minus this piece here. So it was 14. I cut out x from this side, and I cut out x from this side. So what's left over is 14 minus 2x, isn't it? 14 minus x minus x. So that's this length. This is now your width, I guess. This is your width. You had 14, and then you subtracted x, subtracted x. So for the length, you had 30. Then you cut out x, you cut out x. So what's left over? Length is 30 minus 2. What's your height? Your height is the x. So whatever amount I cut out this amount. When I fold that up, that becomes the height of my length times width times height becomes 30 minus 2x. 14 minus 2x, x. So I have an equation that I could take the derivative of and max, and what I want is for this to be max, like as big as it could possibly be. And I have one variable. So like for today, that's what I want, you're good from there. But does that make sense when I'm getting those numbers? It's not an easy unit because you just get all these different scenarios where you're like, oh, I have to come up with. But the more you practice, the easier, the better you get at it. Therefore, can I what? Are you saying words? Drawing is often super helpful. Two towers are 30 feet apart. One tower is 12 feet high, the other is 28 feet high. All right, so I got a tower that's 12 feet high. I got 30 feet. I've got a tower that's 28 feet high. Fair enough so far? Top of each tower has a wire tied to it that connects to the stake on the ground. The stake is somewhere in the middle. So the stake could be anywhere. Let's just pick a spot and put it there. But realize this could be over here. It could be over here. That's what I'm trying to figure out. Where can I put it so I'm using the least amount of wire? Because wire is expensive and I don't want to buy more than I have to. So there's going to be a wire here that connects from the top to that point. And a wire here that connects from the top to that point. So I think in the video he called this like wire 1 and wire 2. I can stick with that, that's fine. And what I want is for W1 plus W2 to equal min, right? I want to use the least amount of wire possible. So like, should I put this like way over here and have a really tiny wire here, but then a really long one there? Should I put it over here where it'd be smaller this way, but longer this way? Should it go right in the middle? Where could it be? Like, I'm trying to buy this wire. I don't know what it costs, but I'm assuming it's expensive and I don't want to buy more than I have to. So where can I put this to make it so I have the least amount of wire possible? Well, these are right triangles. And I don't know exactly where I'm going to put that. So I can't put a number there. But so let's just say, because I know this whole thing is 30. Let's say I called this part of it x. What would that make this part? It would be 30 minus x, right? Like if this is 10, this has got to be 20. How did I get that? I did 30 minus 10. So this piece is 30 minus. That's like the main. I'd say that's like the thrust of this question is, can you figure out that? It's probably the hardest part of this question. So you got to know to split it into two parts where one is x and the other is 30 minus x. And then, isn't W1, like couldn't I find it using Pythagorean theorem? So W1 is going to be the square root of 12 squared plus x squared. Is that fair enough? Or should I like write out how I got to that? Somebody say something. Okay. spoke, so we'll go with you. W2 would be the square root of 28 squared plus 30 minus x squared. It's just like the hypotenuse is the square root of leg squared plus leg squared. That's all I'm doing. And then once I know that, I can just add these two up. I'm in one variable, and I can minimize that. So I'm going to go the square root of 12 squared plus x squared plus the square root of this guy over here. Equals me. We'll worry about that on Monday, but what we've got right now is we did set up our equation that we want to minimize, and there is only one variable. Questions on any of those four? So, unfortunately, questions on any of those four? We're going to go slowly. So unfortunately, they're not. It's not like you do those four, and then there's just like different versions of those four. It's just over and over again asking you to look at a situation and try to come up with equations that you can minimize. So I don't want to. Anyway, I don't want to like do it for you because then you'll have no chance to practice things on your own. But with that, you're probably going to get stuck on a few of these, and then at that point, I'm happy to go over them. I want you to like try it before I start just showing you. You know what I mean? So go through and try to set up the equations for these.
Yeah. 11.
11 of them.
Twice the test prep.
Okay. So try and set them up. Look through the answers and see what I can do. Like I'm gonna have to go through things for sure. I'm happy to. I want to. I just want you to like try things on your own and get stuck before I start going.
Okay. So for a lot of these problems,
Yeah.
it's like the same repeating equation that we use in like the notes. And I know you said there's not like really an equation, but it's just it's there. Because like
There's multiple of the same type.
Number 4 is the same one that we did.
That's the state
Number
one.
4.
Like
Yeah.
there are only a certain number of ways they can ask it. I'm just saying it's more than the 4 I just showed you.
Okay.
So, and I don't want to run through every scenario.
Yeah.
I'm gonna try. But like, yeah, 4 is a duplicate, 5 is a duplicate.
Cool.
So there are duplicates.
Okay.
But try it. Let me know where you get stuck, what I can do, and we'll do it then. Like 10, I've literally never seen before.
Yeah.
Did you want to? And
just-
you're fine. Like to me, you've done one equation that's going to minimize. You got one variable, and you're good. So, like when we go to take the derivative Monday, your first step will be simple. Okay. You're getting the concept. That's what I want to say. So for simplifying, like you're gonna take the derivative on Monday. So if simplifying helps you take the